I'm moved into baseball cap zone to handle the hair. Wait a second, it's lighting not great on me there. Ah, that's bad. Welcome to another one-day build. This one is another tool mod because once I finished the standing bandsaw, it kind of inspired me. It really did. I'm so happy with how that tool turned out and how useful it's been. I've been using it multiple times every single day. I thought, let's look for some other tools. And I mentioned this on the live feed stream a couple of weeks ago, that I might do this build. So this right here in front of me is a mini chop saw. This is a model making tool. Harbor Freight sells one. Micromark sells one. Proxxon also sells a really nice high-end one. And so you can buy these for somewhere between 30 and 200 bucks, depending on who you buy it from and the quality of the parts inside. And this is a really useful tool. It uses uses two different kinds of blades. Oh, I'd actually have to hold the thing up. It uses metallic blades for like plastic and soft metals, and it also has these emery blades, which will cut through hardened steel. And frankly, in cutting hardened steel shaft and other like hard things here in the shop, this is a critical, weird little bit of infrastructure, because the only other way to do it is with an air cutoff tool right now. And frankly, that's not a very delicate tool. This one has a little vise. It's got a little angle finder. You can go up to 45 degrees. And look, this is a cheap tool. It's a cheaply, quickly made tool. And I think I can make it better. So the first part of replicating this is to replicate the vise. I want to make a new vise and a new spinny thing for the vise. And then I'll get around to worrying about how to make this hinge work. Yeah, that's where we'll go. I have two of these actually, because I ended up with two over the years. I took the vise off the other one. So here it is. Here is the vise. You can see it's got this turning handle. It's threaded rod. Yeah. I am going to try and replicate this first and foremost. There's a lot of water that's going under the bridge. Like 4 or 5 days of work between me saying I wanted to build a vise and the vise. Now, if you remember, here is the vise. Of course you remember, because it was in the previous shot. Here's the vise I wanted to replicate. Here's the vise that I made. Oh yeah. Okay, look at this thing. Look at this thing. Oh my God. It is so pretty. It is so beautiful. I have spent about 12 hours on this mill, slowly putting this thing together, taking chunks of cast iron I had in my storage, cutting them with a bandsaw, then building a reference surface, turning chunks of cast iron into billets, squared off billets of cast iron. Then cutting those squared off billets into chunks using my new bandsaw, chucking them into the mill, getting things to dial into each other, literally plus or minus about 1/1000th of an inch in almost every permutation, in many cases slightly less than 1/1000th of an inch. I've got a front jaw here with a keeper on the bottom made of bronze. Inside that jaw, there's a notch in the front of my lead screw that I lathed, and that notch is captured by a set screw that I machined this tiniest little pin. It was so satisfying to make all these parts and to slowly assemble a working, beautiful tool using my own hands. I know that I'm a machine operator. I know how to use this machine within, some parameters, but the full marrying of my mechanical skills with my aesthetic skills has made the journey of making this vise something that is almost like a new lens with which I want to look at the world. Yeah, it's just increased my understanding of what's possible for me to do. And that's kind of an intoxicating feeling. So now I don't just want to add this vise to the base of this chop saw. I want to make the entire thing beautiful. So I'm going to start taking it apart. All right. Time to start taking apart this chop saw. And I'm going to bring the other one over too. I kind of prefer its color scheme. Yeah, let's take these both apart and let's figure out how to remake them in our image. Oh, look at that. That's nice. I never realized that that comes off like that. So it's a belt-driven system here. See, these are basically the same tool a few years apart. Both made in the same factory, probably using the same exact tooling. You can see that the parts are interchangeable, give or take. Yep, totally interchangeable. You know what? Maybe I should pull this off. Okay, I'll do that. Okay, that's the pin that holds it up. And yeah, we've got this heavy duty little spring in there. Okay, so that's the base of one. Great. Let's do the other one. Oh, wait, we can also pull off the blades. Let's see. I'm gonna use a bigger. This process of taking tools and making them better, honestly, I've been doing it since I was a kid. There's nothing more fun to me than taking something that's useful to you and adding stuff to it to make it even a little bit better. All right, those guys. All right, second. I've taken apart parts of both of these saws, and I have a pretty good idea about. My basic idea here is that I want to utilize this structure. I don't want to try and reinvent the wheel here. I think this is a pretty fine and robust thing. I've used this for a better part of a decade. The bearings feel fine. They really do. Ah, I see. That's what that's for. Nice. The bearings really do feel fine. I think I'm going to pull this belt off and just see how it feels. Oh, right. I have to pull it off that one. Okay. Let's just take a look. All right. I'm going to do some cleanup on this. And then I'm going to do some measurements so that I can make my vise work with this whole business. Yeah. Right. That sounds fine. Nice and quiet, actually. This one has a heavier duty cord. Let's just see what this one sounds like. I like this one better. In general, I will tell you, I don't think I need a more robust cord. All right, so I think I'm gonna go with this. Now I want to clean this business, yeah. I'm very pleased with the fact that the one whose color scheme I like is also the quieter running motor. I didn't want to have to swap those out. And now I have a parts one. Seriously, I got these from Harbor Freight and they have served me well for more than a decade. Totally worth your investment as a tool to have in the shop. I've had them in a bucket up on a shelf for the longest time simply because I wasn't doing a lot of that fine model work, but then I recently had to cut a hardened shaft a steel shaft, and I was like, oh, right, I forgot about that. Like at ILM, this is what we use for all those kind of cuts. Solder back in. And the switch. Let's get these silvered. Yeah. Awesome. By definition, this thing will be filled with metal dust, and you don't want that anywhere near your electronics. Pretty sure. So let's spread some heat shrink on there. We can use that to seal it up later. Great. All right. Ah, nice. Simple switch like this, not really a way you could wire it up backwards. 2 contacts, connect them, you get power. There we go. Now let's get a little better view on this. I might consider like painting the whole outside of this, but frankly, given that I've used this tool for a long time, I'm kind of inclined just to sort of put it back together, steel wool it, and see how aesthetically pleasing it is. Did I already have a screw in there? One of the nice things about having 2 tools is, as I was saying earlier, that you end up with one for parts. And a tool for parts is always good when a tool is important to your system. Okay, so. We're definitely improving the overall look of this thing. Oh, let me get the belt back on. All right. Does the belt have a direction it wants to go in? It does not. The belt seems crisp. I feel like we're good on that front, so. I discovered something in here. In here, there's a pin. And that pin allows you to tighten. Ah, I see. Great, great, great. Okay. So in order to actually change the blade, this is not plugged in, you've got to actually engage with a hole in the spindle shaft here. That's so hard to see. There we go. Now it's easy to swap out the blade because the shaft won't turn. That's the direction it goes in. one more screw. All right, so that's the base as is, and this went into this base using this pin, so I can actually set that up. We can do the official assembly later, but this is just to get it, just to do some measurements about its critical measurements. All right, so that's the blade, right? And as long as that springs back up, you're good. So then the question is, the vise sits here. Don't need that. The vise sits here. Let's see what kind of clearance the blade gives to the vise. Yep, okay. It just clears the bottom of the vise there. So the question is, does it clear the bottom of my vise? And the answer is yes. Okay, so this goes up and down like this. The vise. Sits there. And yeah, it just, yeah, there we go. That's where it does. It clears, yeah. Okay, so does the same thing work with my vise? And the answer is yes, right, because I made it basically the same height. But I'm gonna want some more structure underneath this. I'm gonna want to replace that entire base. So my goal is here to mount the vise. This is the, if I match up the hinge point here and the pivot, I end up with it sitting here like this. And the pivot goes right underneath the apex of the 45 cut and the straight cut. So that sits like right about there. And so that sits there and tilts to a 45. I'm gonna do this thing where I mount it on a big piece of maybe Delrin. Yeah, with an arrow there and a knurled knob, or maybe this is a piece of 1/2-inch aluminum that I cut down. And then that sits on a bigger base, and I make nice big markings for all the angle measurements. But in order to fit this with a hinge, I've got to make the hinge, yeah. I basically have to build the structure first, and then I have to figure out exactly how high the hinge is. That's the goal. All right, I've just finished doing some layout. This right here is the plastic piece that I'm going to cut out that the vise mounts to. That arrow will point and indicate the angle that you are cutting at. Really, it's mostly 0 to 45. Vise will sit here. I think I'm going to cut this out on the mill. I think it's a nice looking part. It'll be really cool. There, yeah. Nice. I'm pretty pleased with that. Got to be pretty pleased with that. That's great. All right. Getting ready to drill this. But first, I just want to make sure I'm totally square. Little tap fluid, and tap these holes. A little bit of tap oil for every hole. All right, now I want to mount the vise to this so that I can officially measure out exactly where the pivot should go. The pivot point is going to be placed at an exact orientation between that 45 and that 90. And in order to do that, I've got to mount the vise to the arrow so I can figure out where that apex is and put my pivot in the back of this thing right where it needs to go. Oh, look at that. Wow, I had that whole shot and you were watching everything happen below frame. I'm really sorry. There we go. I've attached the vise to the arrow. Now it's time to do some marking. Okay, so obviously that's one apex. And then this is the second one. Yep, good. I like that. Okay, pull that off. Oh, look at that. Dueling screwdrivers. Do-do-do-do-do-do-do-do. So, if that's the apex, then how does this work? It goes like this. One of them comes up here. So, the pivot wants to happen at the bisection angle. There. 7.4. Half of 0.74 is, half of 75 is 35, plus 4 is 37.37. Right there. Okay, so that's the angle. And now I want my pivot. Need a steel pin for my pivot, so I go over here to my steel drawer. And we're gonna go find a pin that I like. Kind of like that one. Maybe it's too small. I mean, that's hard. Ooh. That's hard to beat. It's nice and positive. I think I cut something off that before. I've decided to go with a pin that's basically the size of theirs. It's really close. I'm going to place it in almost the identical spot. You can see it is literally just behind the apex. I've got my measurement, so that pin is going to go right there. So I drilled this hole out with a fractional drill bit, but I am reaming it out with a number drill. It's exactly 0.18. When you want to make a hole really exact, you use one of these things. It's called a reamer. It's got these long, straight chisel blades. It's not meant for cutting a hole. It's meant for refining it. And you just slowly feed it in. There we go. There we go. Let's get a little cutting fluid there. Yeah. Now that should be a very close hole to this pin. Oh, and it is. Oh, that's great. Okay, so we're in really good shape here. It's we've got the arrow, we've got the vise. Now it's time to cut out this guy, the base, and we're on our way. I'm going to cut the base out of 1/4 inch aluminum. To start cutting out a piece like this, I'm just going to use raw stock 6061 aluminum, and I need it to be 4.5 by 7 inches, and that's what I'm going to cut out here. That is my new base before I've cut it out. But now we've got to do what we call layout on this guy. Ah, my hair! Layout is a machinist's technique for precisely marking out on a piece of metal where all the cuts are supposed to happen. I'm going to spray this with a blue lacquer dye called Dieckman or marking fluid. And I'm going to then scribe in the cuts so that I know exactly what material I want to remove from this aluminum chunk. All right, now I've got a nice blue piece of aluminum. Let me let that set and we'll start our marking. All right, let's say that's 0.25. Great. So we'll do a, we'll make that the cut side. Then we want to bust out exactly 1/4 inch from there. Yep. Okay, so then, great. We'll have that be the throat. Oh, yeah, let's use this one. Oh, is that fatter? No, that's about the same. So. Now, I can cut all that out right now, but I'm not going to. Now what I'm going to do is I'm actually going to put the hole in here for the pin. I'm going to install the pin. I'm going to put the vise on, and I'm going to work out the hinge of the saw because I want to make sure I've got a functional machine before I work on the aesthetics here. So we're doing really good. I really like this base. Cutting it out and filing it down will be awesome. But for right now, I got some machine work to do. So satisfying. Oh, 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 yeah. When you drill a perfectly vertical hole, and two things are joined forever, it's really lovely. Okay, so yeah. I find this bit of the narrative entertaining because I have to cut this pin, and this is a bit of hardened steel. In order to do it, well, I should be able to use my chop saw, but I can't, so I'm going to use this, my air-powered cutoff saw, which I don't like using. So let's get a mark on here. Oh, oh, it's getting lovely. It's getting kind of lovely. Yeah. All right. Let's get a 45 out here and let's get it marked out. One more bit of engineering, which is I want to be able to take it from 0 to 45. Pretty cool. And then I want to be able to lock it at each of those, or at any thing in between, because I'm going to make some marks along here. So the question is how to do that. And I think the answer is I'm going to have some feet built into this thing. 1, 2, 3, 4, right? I have some feet built into this thing. And I'm thinking of a brass nut right here. Yeah, I'm thinking of a brass knurled nut right here. So I want to bisect this arrow for a brass nut right there. Again, I can worry about the actual positioning in a little bit. You know what I'm wondering? I'm wondering about actually cutting off this part of the hinge. And literally utilizing this engineering by bolting it down to this. There's no... Yeah, I can totally do that. It'll save me a couple steps. Oh, oh, it's getting lovely. It's getting kind of lovely. Yeah. All right. Let's get a 45 out here and let's get it marked out. one more bit of engineering, which is I want to be able to take it from 0 to 45. Pretty cool. And then I want to be able to lock it at each of those, or at any thing in between, because I'm going to make some marks along here. So the question is how to do that. And I think the answer is I'm going to have some feet built into this thing. 1, 2, 3, 4, right? I have some feet built into this thing. And I'm thinking of a brass nut right here. Yeah, I'm thinking of a brass knurled nut right here. So I want to bisect this arrow for a brass nut right there. Again, I can worry about the actual positioning in a little bit. Can I? Let's see here. You know what I'm wondering? I'm wondering about actually cutting off this part of the hinge. And literally utilizing this engineering by bolting it down to this. There's no... Yeah, I can totally do that. It'll save me a couple steps. Great. Ah, this is the one I like. This is the slightly newer one. Yeah, then I can clamp it in place, get it all working. Great. So this means I gotta do that angle first. All right, now you see how this is gonna work. I'm gonna have a nut under here that I do that with, right? And that should allow me, I'm gonna cut this on, wow, what am I gonna cut this on? That'll be a thing. Okay, I'm trying something I've never tried before, which is kind of a live cut. Actually, let me see if I can get you to see it this way. Right. So what I'm gonna do is I'm going to plunge the milling bit, this carbide bit, in right here. And then I'm going to slowly use this arm to make that cut all the way down. Yeah. Yeah, something like that. No, hold on. There we go. Woo! Okay, I'll admit that was scary, but once I got a handle on it, it was actually pretty reasonable. I would not recommend you try my technique. This is not, don't take this as gospel, but I'm very pleased with how that turned out. And yeah, my layout's not too messed up by the spinning. Yeah, I've got a, yeah, that's great. That's great. I am super pleased. So I think, right, we got to figure out how to mount the hinge, and then we're close to starting to do some hinge mounting and then cutting out. Now I'm going to cut this using the bandsaw I modified last week. Now, that pivot point should help me figure out where my hinge actually mounts. All right, I know it doesn't look like much, but this plate is now properly prepped so that I can do the cutting out, and then I'll do the filing. There we go. think it's going to take too long. So this is very exciting rough assembly. There's still a lot of parts to build for this. Still a few parts to build for this. We're not quite across the line, but we've got another 90 minutes or so of this day. Okay, so now we need a pin. All right, that was a bit of a shit fight, to use a technical term. But here's where we're at. We got that going on. We got that going on. We got that going on. Uh-huh. Yeah. Yeah. And we have that going on. It cuts at the 45 and it cuts there. That is beautiful. Now, there we go. Yeah. So, I'm going to have to remove a little bit of material on that thing right there. Yep, that's fine. Yeah. Okay. A knurled nut. So, here's what we've got. The saw is sitting on its old hinge, sitting nicely above this. It's beautiful. It's working out really nicely. I have a little bit of a clearance issue in that the saw doesn't quite reach all the way to the bottom. Literally off by about 20 thou, but I think I can take care of that by removing some material on the underside here. The vise, my beautiful vise, is sitting on top of now my beautiful arrow, and all of this is being held in orientation by a single pin on the underside there. And look at that. Look at that. And the nut, you tighten this nut, tighten this knurled nut, and now it doesn't move. Yeah. So, oh yeah, look at that. Oh. So there's a few things I still need to do. This is a very vibratory machine. I need to put it on some rubber feet. I need to, I think, paint the very tip of my arrow red. I need to start basically coming up with exactly what the markings are, and then how I'm going to embed them in the base of this machine. But I have to say, for a rough assembly, I am really, really pleased with that. Okay. I am proceeding apace with the miniature chop saw. It's been a few days, but as you can see, we have a vise carrier, and we have a arrow, and the arrow is eventually going to point at the markings of 0 degrees, 10 degrees, 20 degrees, 30 degrees, 40 degrees, 45 degrees. Yeah. So I am about to add a little more structure to this guy. And actually, let me turn the camera around and I'll show you what I'm talking about. So here is the chop saw as it's currently set. I've got an emery blade in there. It totally covers whatever sits in the vise, which is fantastic. I think it covers it almost to the vise being all the way open. Let's just double check that. Look at that, just a tiny little, oh, sorry. There we go. Look at that. Yeah, I can have almost the vise all the way open and still chop all the way through. And the vise sits on this carrier. And when you loosen this knurled nut, you can move the carrier. And eventually I will have angle markings punched into the outside of this plate. But there's another feature I want to add right now, and it's a really fun one. Careful watchers might notice that I have a little bit of a slit right here. And I actually cut an old ruler that I had, and it fits in that slit, and that's going to be a stop. I'm going to put a brass stop that I'm going to machine here that will be adjustable so you can put work in here, and the stop will give it a consistent length. So you can cut out many pieces of the same length using this. And I think over here is where I'll have, yeah, I'm still not sure about how the stop is going to actually stop, but we'll get there. So next step is I'm going to actually do some layout on this little piece of, this is brass or bronze. Doesn't really matter which for my purposes. And I've already painted it with a blue marking die. So it's time for some layout. All right, so I've done a bit of layout, and this is what layout looks like. I've made some markings. I draw hash marks where I know I'm cutting stuff out. And next step is to chuck this into the mill and start cutting it down. Okay, so here's my stop, mostly cut out. It needs some polish and some burrs removed and stuff like that. Now I want to make the slot for the little ruler, and that's that little business right there. And I'm going to cut that with a slitting saw. This is a totally cool milling procedure, and I'm going to show you how it works. This right here is a slitting saw blade, and it happens to be the exact thickness that I need it to be. And I'm going to chuck it into an arbor, chuck this piece into the vise over there, and I'm going to slowly use the slitting saw to make this perfect cut right through there. You're going to love it. Almost there. One more pass. That's right, ladies and germs. It's time to bring in the big guns. Yes, I am going to clamp this puppy into my stitching pony. Yes. So let's see here. If I grab it like this, yeah, that gives me the angle that I want. Actually, here, let's try it like this. Yeah, there we we go. Awesome. Okay, so let's see if this guy really, ooh, come on, gives me the accuracy that I'm hoping for. It's a little bigger than I would like it to be, but I can live with that. And the slot fits perfectly in that. That is, ooh, let's go there. There we go. There is my stop. I'm gonna glue that. Yeah, I'm gonna glue that in there. And then I'm going to set its adjustability. This is one of those shots from ClickSpring here, where it puts down a part and you can't believe how clean it is. I'm pretty happy with that. Okay, I have my stop. It's now mounted to my steel measuring rod, which I'm very excited about. It looks great. And it sits in this little slot right there. Hold on, let's see if I can get that. Yeah, there we go, that's rough. Sorry about the focus thing. Focus. Okay, it's gonna sit in this slot, and I think I know how I'm going to make it tightenable. And that is, I'm going to take this slitting saw here and make a little slice right above the slot, and then I'm gonna tap a hole for a small, like 440 screw, and that will be my tightening screw. Yes, I'm gonna use a little flap of flexible steel to hold on to this without marking it. That's the theory. Let's see how I do. So, here we go. All right, I had to finish that one off camera, but you can see the little flappy flap. So what I'm gonna do is, that should have just a tiny bit of flexibility, and I'll clean up its burrs. I'm gonna put a hole right down there and a tightening screw with a lever arm, and I'm hoping 1/4 turn. That's my goal, is that there's a little lever up and I put it down and I clamp, and I bring it back up and I'm not clamped. And the way I'm hoping to do that is by actually modifying a little Allen wrench. But we'll see. Ooh. Okay. I have, this was intense. I have a hole tapped in the back of this vise. This is the slot in which my, my stop here will ride. And its backstop is the bottom of the mount for the vise, this guy here. Now, I have taken a 440 screw and I have machined the end of it to be a little bit of a relief, so that I'd used a plug tap on this. I used a bottom tap all the way right up until my little flappy flap, but I have no idea, right? Like I couldn't get all the way to the bottom, so I machined a little, hold on. I machined a little bit of a relief on the end of the 440 just to provide a little better registration. And this should cinch almost all the way up. Okay, so that moves. Now let's see here. If I have it facing up like this. So what I'm planning on doing is actually cutting this Allen wrench down to right here and brazing it right to the Allen. If I bring it down like this, not quite. Ooh, it's a little bit, but it's more like from here. No. There. There it doesn't move. So it kind of needs to go, what, there? Jeez, it's like past center. I don't like that. Okay. That's not moving. And if I bring it up, then it moves. So down, no move, up, move. That's great. Down, no move, up, move. Yes. At the 90, it can't move. At 0, it can. Okay. That is awesome. I got to cut this. I think I'm going to try and solder it right in place. Okay. How do you cut an Allen wrench? Well, use a grinder. All right. Got my soldering iron cut down. I'm going to put a little bit of flux on there. And let's just double check I got my measurement. Yep, 90 is no move, 0 is move. Okay, so one, two, three, four. Let's see here. The issue here is that the vise itself is going to act like a heat sink, but hopefully I can get the whole thing hot enough before it does that. I mean, it's going to act as a heat sink no matter what. Question is, can I? Yeah, I just don't want to end up soldering it all to itself. Ooh. Hey, that kind of worked. Yep. Okay, let's get that a little more flux. Let's get a little more heat. Oh, I'm running out of fuel. Great. I feel like that's wetting all the way around. Good. I don't think that's going to go anywhere. Okay, I'm going to bring this all the way out. I'm going to clean this guy up. Yeah. This part, while it seems like tedious to assemble and disassemble your main machine like a million times, it's actually great. It's actually really lovely. The more you do it, the more comfortable you get with it, the more you start to understand the idiosyncrasies of your machine and exactly what it wants from you. You understand which side of which things to tighten, which sides to tighten first and second. I mean, it's just all of these ways. Okay, that's the front, that's the bottom. So these guys live like that. Yeah, okay. And using these tiny little 440s. Oh, it's great. Wonderful. Registered. I'm shooting, right? Hey, I'm shooting. You don't know how many times I look up and realize I haven't been shooting. You wouldn't believe how this thing was 2,000ths thicker on one end than the other. I filed it. I didn't video it. You're welcome. Okay, so that moves. That doesn't. That moves. That doesn't. Damn, that is cool. Okay, so if this guy lives here like that, and this comes up, oh man, yeah, it can't be taller than the body of the vise. That's for sure. So I've got a thing. In addition to making wonderful cutters, Knipex makes some really intense cutters. These are like bolt cutters for your hand. So I am going to literally, watch this. This is hardened steel. Yeah. Boink. That's great. Now I want to put something on there, some little doohickey. I think I know what I want to do. All right, this is we're getting close here. So this is the little loosening arm for the stop. and it moves in and out quite freely. And then this is the tighten. Look at that. I managed to get all the tightening within 90 degrees. I'm super happy about it. I have it clamped into square right now, what I think is square. So the next step is to cut this piece of brass in here and see how accurate the cut is and adjust accordingly. So here we go. I'm gonna bring it right up to the stop. Oh, actually, I don't need to cut off that much. I can cut off just a little bit. There we go. Yeah, great. Then put in some there. Excellent, here we go. Oh, I don't have it plugged in. For the record, I'm cutting a wide piece of brass here. This is not the kind of thing you'd often cut on here. It'd be more like cutting K&S brass engineering plastic, but we'll continue with this cut. Let's do Okay, this is the position I was sitting in when I made the cut, and I'm about to just check squaricity on this guy. Oh, it is ever so slightly, barely. So it's this way, which means it needs to come this way. Okay, here is my mini chop saw. 20 some odd completely custom parts and pieces. Everything fitting together. Okay, after about 3 weeks of work, longest one-day build in a while, I have finished my mini chop saw. All the parts are here, and I'm about to assemble. Are you guys ready? Here we go, let's do an assembly. There it is, my mini chop saw with a vise. It's got a movable stop. It's got adjustable angles. So freaking satisfying. Let's cut something, then we're done. Here we go. This is a piece of brass, square K&S brass stock, which is exactly the kind of stuff we'd be cutting with this. And we turn it on, and there we go. Ladies and gentlemen, let us check square. Wait a second. See here. Yeah. I'd call that respectable. Ooh, let's do a 45. Here we go. Doing a 45 cut. I know. The motor sounds just a little bit anemic, but I don't mind that. Okay, let's take a look with our 45. Ladies and germs, aside from a burr, I think we have a new tool in the shop. Oh, I'm so excited, and I just can't hide it. Oh my gosh. All right. Thank you guys for sticking it out with me on this incredible 1 week build. Here I also have some of the parts. That's a knurled nut I made that turned out to be too short. I had to remake the vise jaw because I got some of the relationships just a little bit off by literally like 10 thousandths. I remade the undercarrier that goes underneath the jaw. Let's see, I remade the lead screw twice. I remade the plate that this sits on. There was a huge amount of trial and error. And then some unqualified success. I am so pleased with this thing. And yes, I know the motor's anemic, and maybe I will replace the motor if I can figure out its specs and size and buy one that's faster and quieter and smoother. But that's a project for another day. This has been maybe my favorite one-day build. Thanks for joining me. I'll see you next time.